How to start the day. Hello everybody. Just before the live stream I went inside to see my family because I got up before everybody this morning to get things ready for this, and I got a coffee machine for my birthday, so now I can start the day with extra tasty caffeine. Firstly, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. And I hope you're all having a fantastic weekend. As is pretty obvious from the chat, today is my 50th birthday. Is everything working okay? I don't have any lag problems, nothing like that. It's all working. Audio is up. Looks like we are winning today. Oh, thanks, Incognito. Good to get the feedback. So today I've got a couple of things to do. Did I shave? Not this morning. I did yesterday, sometime. So today I'm going to can't tell the difference. Okay, so I set myself a bit of a challenge. I didn't really know what to do to celebrate the 50th, so I thought I would do a 50 projects in 50 minutes challenge, where I'm going to go through a list of I picked some projects that I've worked on over the last 10 or so years, I think the oldest one is about 10 years old. And, oh, Scott's birthday was yesterday. Happy birthday for yesterday. And what I'm going to do is spend 1 minute on each project. So obviously I can't go into any particular depth with each one. It's just going to be, hey, this is the schematic, this is the PCB, and NTP analog clock from Incognito. That project is in the works. But I don't have it live yet. I've recorded part of the video for that, but it's not live yet. So what I'm going to do is show the schematic and the PCB for each project, which is going to just give you some concept of what each one's about. I can't go into great depth about each project. And my original idea is that what I would do is show the schematic, the PCB, and the same thing in 3D in Fusion, but that's just not practical in 60 seconds per project, including opening the files and getting everything ready. So what I figure I'd do is run through and show you the projects, and then later what we can do is look at a couple of them in a little bit more detail if that's of interest to people. And the other thing is, as you may have seen on Twitter and Facebook, I've been messing around with something. So just off camera here, I'll move it up so that you can see it. This is the Internet of Party Poppers device that I built yesterday and this morning. So it's a bit of laser cut MDF with a whole bunch of party poppers on it, and I'll try to get the position right so I can get some focus, and servos to fire them. So the strings of the party poppers are connected to the servo horns. On the other side there is a multi-channel servo driver. There's a Raspberry Pi in my hand here inside a metal enclosure, and the Raspberry Pi can fire any of the poppers. So it's an Internet of Party Poppers setup. I've got to see if I can arrange it so that it's in view of the camera, but I think that's going to be quite hard just because of the positioning. So right now they're aiming pretty much at my face, which is a little bit freaky. Maybe if I put them back here a bit, they'll be sort of in view of the camera. Now which one is it? One, yeah, so that will be the first one that fires, and it will work along, and it's aiming sort of at the back of my head at the moment. So if they go off, I'm probably going to firstly pee my pants, and then jump. So hang on, I've just got to enable it at the moment. I've got so many consoles open at the moment. I've got multiple computers running this, and somewhere I've got a shell into the Raspberry Pi. I've got to find it. Here we go. Okay, so at the moment they are disarmed, and I have... Okay, now they are armed, which means that they can be triggered. Yeah, sustain the Internet of Head Injuries. Okay, so the question is, what's going to set these off? And I've been actually a little bit mercenary about this. I'm not going to tell you what will set it off, except that right now you have the capability of setting them off. Anyone that's in the chat could do it. It's not necessarily just by saying something. Yeah, so Kate, you can't just say fire. I could have done that. So what is happening right now, I wonder if no, I can't. It's on a different computer. I was going to drag it down so I could set them, I could let you see the console that's currently running it. So what I have is a Python script, which is using the PyT chat, however you pronounce it, PYT chat library. And right now it is watching the chat in live. So I can see on a console up here all of the chat, like release the Kraken from Cable Tie. Oh, and also Cable Tie, thank you very much. Yesterday I had a personal delivery from Cable Tie as a birthday gift, a pre-birthday gift. And given that we're in isolation at the moment, so it's kind of strange. Not only are we not seeing people directly in terms of meeting up, but we're also, it seems to have reduced other types of interaction as well. So receiving an unexpected birthday delivery from Cable Tie was really cool. That was quite a treat yesterday. Oh, Jordan might be onto something. Yeah, so yeah, business-related electronic goods. That's what Cable Tie was delivering yesterday. It was a business trip. So now, the thing is that this whole thing might be a total fail. I don't even know if this is going to work. Oh, Dodgy was onto a good idea as well with Squirrel. Now that is actually not going to work yet, but that is something that would that will work in the future because of a thing that Andy and I have been working on. So that's a little bit of a secret project. Oh, hang on. What was that? Ah! It worked. I'm kind of surprised. And now it smells like gunpowder. Oh. I saw the thing come up in the chat. So I was anticipating it. But then I thought that maybe it wouldn't work. All right. So, by the end of this, my lab might just smell like gunpowder. Now, what I should do is try not to pay any attention to the chat so that I don't get any warning that it's going to be triggered. Now, oh yeah, and yes, Chris, you did tell me. I hope it wasn't too loud on the microphone. All right, so I'm in Melbourne, Australia right now, which is at GMT plus 10. And what some of you might know is that no, what have I done to myself? We're going to run out very quickly. This only has 12 on it because that was all the servos that I had, and after that it got a bit crazy trying to make a large board. So 3 are fired already. Oh no. A couple more. At least if we get this out of the way before I start trying to do the project. Before I start trying to do the project explanations, I might actually be able to concentrate on it. Now I've got bits of confetti everywhere. I just wish that this was in a position where you could see it better. Hang on. I'm going to move it before the next one goes off. Oh look, you can see the smoke coming up from it. And what I'm actually surprised about is that this is working fairly well. I thought that what would happen is that the little string would slip on the servo horn, or the servos wouldn't be strong enough, or something. And oh, thanks, Brett. Here comes Brett. 3, 2, 1. Come on. The script, we'll get onto it in a second. There it is. All right. So once it runs out of party poppers, it won't do anything else. I could reload them, but it takes too long. I got to cable tie them on and attach them and stuff. All right, only 3 left to go. I don't want to look at it because it's aiming right at where my face would be. Well, if this gets out of the way soon, I will be able to get on to doing the... hang on, I've got to move this so that it's aiming at the camera so you can see it. If I get onto this soon, move it into focus. There's only one left. I got a string hanging. All done. So, thanks. Thank you to everybody that set those off. I've run out of poppers now, so it's not going to do anything from this point. But yes, all the magic smoke has been released. Okay. Stop. Take a drink. That's actually discombobulated me more than I thought it would. Incognito asked, what sort of coffee machine? It's an espresso something. I opened the box right before the live stream, but I haven't actually set it up yet. It looked like there were quite a few parts to it. So actually, because it looks cool, I'm gonna run the script now that resets all the poppers. 0. Oh, I've got a shell onto the Raspberry Pi. So I've got a script that runs through, and I need a bit more length on that. That's the power cable to the Pi. It's not quite long enough. And it looks cool when it runs through, because what I did was put a slight delay in it. It resets the position of the first servo and then moves on. So I'll run that now. It's like a Mexican wave, but of servos. Okay. Chris, no, that was my best idea ever. That worked out. That worked out well. I like that. Okay. Mako says my t-shirt has stuff on it. Yeah, probably. There's there's like bits of confetti all over in front of me, and there's stuff all over the floor. All right, so what I was just starting to say before is, so I'm in Melbourne, Australia at the moment, which is at GMT plus 10, and it's a little bit after 10 a.m. on my birthday, which means that, but what some of you would know is I was born in London, which happens to be at GMT plus 0, which means that my birthday in England started 17 minutes ago, and it won't finish until 10 o'clock Melbourne time tomorrow. And that means my birthday goes for 34 hours every year, not 24 hours. I get a I get a special extended birthday every year. At least I can claim that. Oh, summertime. Okay, Mako said GMT plus 2, summertime here. Oh no. So that means my birthday goes for 32 hours. Okay. Oh, Dodgy says he was nearly born in Hull but escaped to Australia before it happened. Alright. So, I got to try to gather my thoughts. Now, I had another console which has disappeared into the background. Where are all my terms? There it is. iTerm. So, what I've got set up is a script which runs through a list of projects. I went through and pulled a list out of cable ties. That was exhausting. It was for me. And so I've got a text file which has got a list of 50 projects in it. And what it will do is on OBS, so on the live stream, it's going to overlay the name of a project and a timer, which will count down from 60 seconds. So, and then at the end of 60 seconds, it moves on to the next project. I've also got it set up so that using the Apple speech synthesizer, it's going to say the name of the project, although most of them are kind of gibberish because the way I name my projects in Eagle is using an SKU, or like a unique product code, essentially a stock keeping unit. So projects don't necessarily have names that make sense. The idea is to try to come up with a product name or code that is short and you can put onto a PCB without using sorry, I'm going to move stuff off the floor. I'm going to have to sweep up out here later. Things like the air quality sensor project, the code for that is just AQS. And the speech synthesizer doesn't know how to pronounce AQS. Or actually the first one that it's going to be doing is a 2-channel load cell I2C interface, and the product code for that is 2LC I2C. So some things it pronounces and some things it doesn't. I don't want to jump right into this. I'm going to pause for a second before I actually start the timer and make sure I've got everything right. So I have Eagle open. I have the first project open. A macro keypad is set up, and also one of the issues with this is these are projects spanning a long period of time. Oh, Guru, thanks, that's really generous. I will get something awesome. And so what you're going to see in some cases is a little bit of a history lesson in the way that I've worked on electronics projects, because I've changed the way I do things over time. And these are not in chronological order. They're actually in alphabetical order, just sorted by the script. And so you'll see things like on more recent projects in the schematic, there is a lot more blocking things together with boxes around them to show functional blocks and different ways of labeling things. And yeah, you'll see some poorly laid out schematics for some of my early projects. And yeah, so let's see, shall we begin? All right, first thing to do is switch to the internal view. Oh yeah, that's right. So what I was getting at is there are also differences in the state in which I left the project. Some of them have been saved. Like if I go to, let's see, if I go to the PCB view on this one, I've just cleaned up the layers on this particular project, but some of them have been left with most of the layers turned off and just part values exposed, and some of them have been, yeah, it largely depends on whatever I was last doing with the project when I looked at it years and years ago. So, what I've done is created a little macro in Eagle, and I've got it running on my custom keypad down on the side here. In fact, I think this custom keypad is even one of the projects that's going to be shown, so you'll see it in a little bit. I've got a little keypad off to the side of my computer, which looks a bit like a pocket calculator. In fact, I'll lift it up and show you before we get into all of this. I'll switch back to front view. That's it. In fact, I owe Sion one of these. I promised to send him one a little while ago and I haven't done it yet. I've done two different versions of this. This is actually the second one. This is the Leopad Mini. There was a previous version that was bigger than this. It had big round buttons on it, you know, like the game controller type buttons. And it's got a little LCD on the top, USB-C on it. I'm going to actually show the design for this later, I think, so I won't go into that in detail right now. But what I've done, this is basically a matrix keypad which is being scanned by a 32U4, and when I press any of the buttons, it sends keyboard events to the computer. And I've got this loaded up with Eagle macros. So what I've got is view schematic, view PCB, and this one here I've just set up right before the live stream. And what it does is turn on and off a whole bunch of layers within Eagle, and it brings the focus correctly. So what it does is it sets the visibility on the silkscreen layer on top of the copper so that you end up with the view like I showed a moment ago. So hopefully, as I'm rushing through these projects, I'll be able to just press that button and the PCB view should reset itself to some kind of a sensible value. Just got to plug that keypad back in, blue tack it back down onto the desk. It's normally stuck there so it can't move. James said mystery meat navigation. Yeah, there are no indicators on those key tops. What I need to do is 3D print an enclosure for that. And I've got some TPU filament, which is like a soft rubbery sort of filament. So what I'm going to do with that is make a matrix with the keycaps that will sit inside an enclosure that I might print in PETG or PLA. And I probably need to put some kind of legend on it. But I do change it from time to time as well. It's I load different macros onto it. Oh, oh, that's very generous. Thanks, Kate. I felt when I was setting up the internet of party poppers, I was trying to figure out what to do to trigger it, and it felt very mercenary setting it to be triggered by super chats, but I couldn't really think of anything else in particular to use. So what I could do is have it look for specific words within the within the chat. So if someone said a certain thing, it sets off a party popper. But in the end, what I did was use, in the Python script, when you query the YouTube API and you get chat messages, one of the things that comes back is the category of the message. And there are 4 different categories. So you can basically just look at a flag and tell if it's a super chat, a super sticker, a regular chat, or something. I can't remember the 4th. And so rather than doing things like parsing messages, all I've done is in the Python, I've got it to look at the flag that says the message type, and it says if message type is super chat or super sticker, then send a message to fire the thing. That was the simplest way I could get it going. And this was all done last night and this morning. So yesterday afternoon I went over to Chris's place. Well, afternoon, it was, what time was it? It was late. It's like 6 p.m. or something. I went to Chris's, laser cut the baseboard to make the popper mounts, and then came home and did the coding and set it all up. So I'm actually amazed that every one of those fired. I didn't get any misfires, nothing went wrong. There was no major bug in the code. I didn't have the San Diego bug where the this was pointed out to me last night. So the San Diego bug was a fireworks exhibition that was being set off in San Diego, and fireworks displays are all computer controlled, and someone screwed up, and Dodgy Brother said, all while staying home, lockdown of course. I work with Chris. So going to Chris's place is legitimate. That's actually my place of employment 2 days a week. So, and the work that I do with Chris, a lot of it you can't do remotely. So, anyway, let's get into this. I'm going to start the 50 projects in 50 minutes challenge. I'll run the timer in a moment. Everybody works with everyone there now. Yep. Oh, I don't know how to pronounce your name. Oh, Ground Control. Of course. Ground Control said use one of Sion's whoppers to launch the IO poppers. Yes, that would look really cool. Incognito. Yes, that's right. Someone screwed in the San Diego bug. Someone screwed up the timer, and it just sent the detonate or the launch or whatever it is command to every single firework all at the same time. So instead of a nice sequence of fireworks over the space of 10 minutes, it's just a huge explosion. But I did not have that particular bug, which is both good and disappointing. All right, where is my script? Run timer. Okay. Before I do this, wasn't that on YouTube? Yes, it was. It is on YouTube. If you search for San Diego fireworks, you will find it. Or San Diego fireworks fail. All right. I have no idea how this is going to go. I don't even know how much I'm going to be able to say in 60 seconds per project. But let's get started. Just got to get all the windows right. I've got my Eagle window open so that I've got the control panel in the foreground so that I can select each project in turn. I can see my OBS output and run timer. TLCI2C. Alright, so this project is a 2-channel load cell interface which converts them to I2C interface, and this is part of the zero stick project that I'm working on with Chris, which is the joystick that doesn't need to physically move in order to receive input. The problem is that the load cell amplifiers generally don't have an I2C interface, and I wanted to be able to make it a single self-contained device. So what I did was design this little PCB which mounts vertically. It's got the two 24-bit ADCs on here. There's an ATtiny84, and the idea is to use the ATtiny84 to read the positions of the load cells, and it acts as an I2C device so that it can be queried and you can see what is going on with the load cells. It's got the I2C interface just down here and the interface down here to the two load cells for the X and Y axes. And I'm out of time. What is the next one?
AntBrain.
AntBrain. Where is AntBrain? Okay, so AntBrain is an ant weight combat robot controller. I was working on this with Nick. In fact, this is the project I was working on the week that Nick died. And this is a tiny little PCB which has an ATmega 328 in it, so same as an Arduino. And it has a mounting point where you can screw a FlySky receiver onto it, and it's got a couple of tiny little H-bridge motor controllers. So this whole board is very, very small. It goes into a tiny combat robot that has to weigh under, I think it's 200 grams, something like that. It's very, very small. So the FlySky receiver mounts on here. The ATmega receives the receiver values and converts them into whatever it wants to do, controls the weapon and controls the two wheels on the combat robot. Next one.
AQS.
AQS is the air quality sensor. That is actually in a totally different I did not work this out very well. It's in a totally different folder, so it takes me a while to open it. I'm going to use up all of my time just opening the project. But that's okay, because most of you have already seen this anyway. This is an in-progress project. It's an air quality sensor that has an ESP32 on it and a PMS 5003, no, a 7003 particulate matter sensor with a laser sensor inside it, so it can detect particles down to 0.1 micron in size, I believe. And it also has a BME 680 sensor which does temperature, humidity, and air pressure, and also can sense volatile organic compounds. So it can detect bad gases and things in the air, stuff that you don't want to be breathing in, and it has a 240 by 240 LCD display on the front of it. Next.
ATmega84ZIF.
Oh, okay, so this is an old one, oldish. It is a programmer for an ATtiny84, and if we switch to the PCB, to the schematic view, come on, schematic, it's not working, there it is. So this is a 0 insertion 4 socket for programming an ATtiny84 or like 44 type chip. It's got an ICSP header that allows you to plug in a regular programmer, and using the Arduino IDE you can then program your chips before they go into an actual project. And so it's got the header on here for a USB to serial interface as well, so you can talk to the serial port on it if you want to, or you can just flash it through the ICSP header. And the 0 insertion 4 socket means that you can just flick the lever up, take the chip out, and then put it into your project. This particular one is just for the DIP format chips. Next project.
AXO-Wi-Fi.
Ah, you didn't know how to pronounce that. AXO-Wi-Fi. This is an interface board that goes inside a window motor. If we switch to the schematic view, this is very simple. It's an ESP8266. It's using an ESP12 module, and there's a programming header up here. And over here is a LIN bus interface chip, so the MCP2003, because the window motor controller has a LIN bus interface, and this allows it to, so what happens is this PCB is a strange shape, and these are slots because it fits into the battery compartment of the motor that controls the windows. And you take power off the normal power connection, and then the output from this, the LIN bus interface, which you can see down here, it's got data, ground, and plus 12 volts, goes to the controller of the window motor and gives you Wi-Fi connection for your electric windows.
Du set Arduino adapter module.
Oh, okay. And this is an old one. So this is a module. Save? No. Come on, hurry up. Yes. So this is a module that fits into a CubeSat satellite, which uses the PC104 format. You can see the headers over here on the right, and there is a header here which is an upside down header for an Arduino. And what this allows you to do is build test systems. When you are building a CubeSat satellite, you can basically put this into the satellite stack and put an Arduino in there, and then break things out, break out the connections for the satellite bus to arbitrary connections in the Arduino. And then there's also a prototyping area. So this is a way of very quickly experimenting with new ideas if you're building a satellite prototype.
Card light.
The card light. Oh, okay. I am about to reveal my phone number. And I don't think I could have skipped this one. This is a business card as a PCB. And it is entirely single-sided. There is, let's see, there's an ATtiny 85 on there. Basically, it's a business card which is a USB data logger. There is a TMT 6000 light sensor on here. It's got a USB interface, start-stop button, and what happens is this, on the other side of this, in fact, I won't flip this board because that'll totally reveal my phone number. I managed to route this so that it was entirely single-sided, and you can see I've run the tracks around massive areas up here where they really don't need to. That is just for aesthetic reasons. It's to make it all boxed. There's an ICSP header and the ATtiny and the USB interface, and the sensor is up here.
Beacon.
Beacon. This is a... oh, hang on. I just stuffed that up. I've got to open this. Okay, so this is a project to do infrared and radio bidirectional communications with different types of home automation devices. It was designed for a particle photon. This was a long time ago, way back before ESP type stuff. When was this? Oh, that was updated 2018, but the original project is from like 2012 or 13. Whenever the Spark Core came out. It might have been later than that. And what it does is expose, transmit and receive for infrared, and transmit and receive for 433 megahertz, so that you can do like an IR blaster, and you can also do an RF blaster, and you can decode signals from transmitters as well and link it to MQTT.
Baby bear.
Baby bear is... come on, where are you? Down there. Aha, Baby bear. Baby bear is an Arduino compatible board, which I am in the process of reworking right now, which is why this USB Type-C connector is hanging off the side here. This is the project that I talked about a couple of live streams ago. It is an Arduino compatible board. It's actually almost the same as an Arduino Uno. The only difference is that it has a different CPU on it, so that it has lots more memory. It's got an 18 mega 1284p on it, but apart from that, it is a direct replacement for an Uno. It's got the 16U2 up here for USB to serial conversion. It's got the auto power selection, the same as a regular Arduino Uno, and it behaves just like an Uno, except it has masses of RAM. It's got 4 hardware UARTs and lots of flash. Very cool board.
CBMINI.
CB Mini. Come on, I've got to find this one. Oh, that's in the other folder. AQS CB. This is the chair breakout mini. This is... what I really should do is have it set up so that it automates opening the files. This connects in line with the joystick on a wheelchair and allows the joystick position to be sent to some other device. It's got a 32U4 on it, so it can do USB HID emulation, so you can turn your wheelchair joystick into a game controller or a mouse or whatever you want. It's got a CAN bus interface down here so that it can report via CAN bus, and it passes through the signal so that you can put this into place on the wheelchair and the chair will operate as normal or you can disable the chair and use the chair controls to send signals out to something else. And I'm probably going to do lots of video stuff about this in the future, I hope. What?
Cherry 2C.
Aha, okay, this one is brand new, Chair I2C. It is so new that I've received the PCBs and I have not actually assembled one. They are sitting in a box. Come on, I've got to find the project. What this does is connect into a wheelchair controller, and it fakes the joystick position using a couple of digital potentiometers. Now, I actually have no idea if this is even going to work. So what I've got here is a couple of DS3502 digital potentiometers, and the outputs go to the wheelchair. And so essentially what this does is take a wheelchair and expose its movement controls using an I2C interface, so that you can use I2C to send direction and speed, and take control of the chair without modifying the existing control system in any way.
Chorus 12.
Ooh, this one, Chorus 12. Ah, okay, so Chorus ESP12. This was in the early days of the ESP12 coming out. This was actually designed, in fact, Angus, who is in the chat, was back before he left me, which I'm still so sad about. Angus used to work for me, and then he left for this little upstart company called Espressif. I don't know why he would have ever done that. So this module has an ESP12, and it is in the same footprint as a spark core or a particle photon board. And the idea is that we designed this while we were trying to convert our blind controllers from using the particle photon over to using the ESP A266. So this is a drop-in replacement for a spark core, but it's an ESP A266 board. Angus, come back. I know you're never going to. What? D1M servo. Okay, this was a servo controller board for a D1 Mini. I did this the week the D1 Mini was announced. In fact, when it was announced, I was really taken with the D1 Mini, and I thought it was a very cool little thing. So I designed, I think, about 6 or 8 shields within the space of about 2 days. Before I'd even physically had the board, I looked at photos of it and figured out the dimensions and the spacing on the pins, because none of that info had been published at the time. And I designed this servo controller. Among others, it's got outputs for, how many have we got here? 16 servos. And in fact, I could have used this to run the Internet of Party Poppers, and a PCA 9685. So electrically, this is actually the same as the Party Popper controller that is doing this. So you plug this into a Wemos D1 Mini, and you can control 16 servos.
DIN controller.
DIN controller is a DIN rail mounted home automation control system. This is something that is equivalent to something like a Sonoff 4-channel Pro, except that it's 8 channels, and this is only half of it. There are actually 2 PCBs, and this is the controller part, so it's got an ESP32 on it, and there is a little OLED and a bunch of buttons. So there are control buttons on the front to turn different channels on and off, and a header which goes down to the mains board. So there are 2 PCBs. The top one is this one, which provides the user interface, and it sits in the front of the DIN rail case and has the ribbon cable that goes down to the mains PCB, which has got 8 relays on it and a power supply. So the whole thing plugs into a DIN rail mount inside a switchboard and gives you 8 switched outputs controlled by an ESP32 using MQTT or whatever you want to do.
DLOCK.
D-lock. That is a door lock control shield, and I've got to find it now. I'm losing myself in this list of projects, with an RFID interface. And I did this because I wanted to be able to control door locks using my RFID implant. And when was this from? 2013, and that was what version? Version 1. Okay, so it hasn't been changed since then. It's got an output here to control a door strike so that it can release a door lock, There is a manual button for like an emergency egress button on the inside of a door, controlled by this FET, and it's an Arduino Shield format. So this would plug into something like a Freetronics Ether 10 to provide Ethernet control of a door lock, and you plug in the RFID reader so that it can read from the RFID reader, decide if you're authorized, and then unlock the door. Donkey. Ah, I didn't realize this was in the list. This is a super simple one. It is a Raspberry Pi hat, and this board was... the reason this board exists is that the original manufacturing arrangement for the board that had been designed by John Spencer didn't quite deliver in time. John designed a much nicer PCB, and when this was for an event that was coming up and we realized that it wasn't going to be ready in time, so I very quickly designed this as a simplified version, sent it off for fabrication, and I think we went from, oh no, we need a new version, to having PCBs in our hands and assembled in like 4 days, 5 days. It was some ridiculously short period of time. But this is for a remote control car with machine learning, so it can self-drive using a Raspberry Pi camera. I didn't even really explain what that was. What's next?
ESP-MAX.
ESP-MAX. Oh, I like this little board. I made a couple of prototypes, never put it into production, and I really should. I did this at the same time as the D1 Mini came out, and it is a D1 Mini style dev board with prototyping area. So it's got the ESP8266 down here and USB to serial converter. I had a CP2102 on this one, and up here are the headers for a D1 Mini, which are also broken out. So if you look at it in this view, you can see over here the headers. So you can put D1 Mini style shields on here, and electrically, and from a software point of view, this board works just like a D1 Mini, except that it's physically a little bit larger, and it has the prototyping area. And that allows you to build, and it also has onboard voltage regulator, which the D1 Mini doesn't have. So this allows you to use D1 Mini shields and build little custom projects.
ESP Remote.
ESP Remote is a board that you connect to something like a remote control for a garage door, and it presses the buttons on the remote control. It's got an ESP8266, bit of a theme on these projects. So there's an ESP12 module on here, and then it's got these MOSFETs so that it can do like a low side drive to the buttons, because typically what happens is the buttons on a remote control, like a garage door remote control, are pulled to ground through the button. It does vary, but most of them are like that. So what you can do is simply connect to ground and then one side of the button, and then by firing one of these MOSFETs you can trigger the remote control. So what you do is cable tie the remote control PCB into the blank space of the PCB right here, and then patch wires down to these 1, 2, 3, 4 connections, and then you've got an MQTT Wi-Fi connected remote control. ETAP. Oh, this was done as a project to replace a tap at my mum's place, and I've never actually installed it. This looks like a bit of a strange one. It's for one of those taps. It's a sensor tap where you put your hand near the tap and it starts. And what I did was have a Sharp rangefinder somewhere. I've got to orient myself. Oh, here we go. Sharp IR proximity sensor connects into here, and there's an ATmega. So basically this is, once again, it's like an Arduino. It's even got an Arduino shelled on there. It's got a couple of MOSFETs here, which it can use for switched outputs, and that's what fires the solenoids inside the tap for hot, cold, and warm. Because there are, the way those taps typically work is they have the hot and cold pipes coming to a T-piece, and there are 3 solenoids, and you can have hot, cold, or warm output on the tap. The Etherino, this one is in transit right now. These PCBs should be currently on a plane. It's the replacement for the Ether 10, which has been around now for 10 years. And it is revised to have the WIZnet W6100 chip instead of the 5100. There's an ATmega 328, so it functions just like, there are actually 4 sheets in this. I won't go through all of the schematic here, but basically it's like, and there's the power over Ethernet section and the Ethernet controller, W6100. So it's like an Arduino Uno with Ethernet with the W6100, which means it will have IPv6 support and power over Ethernet and USB-C. So it's really like an Ether 10 that has been upgraded to bring it into the modern world. I should have those PCBs in my hand maybe Monday or Tuesday. Ooh, 11. So the 11, this is not so much interesting from an electrical point of view, more from a history lesson point of view. The the old Arduino was called the Dual Milanova because it came out in 2009, and so I designed a board called the 2010 and proposed it to the Arduino team as the replacement for the Arduino Dual Milanova, and they decided not to use it. They went for what became the Uno instead. But in this little fantasy world of mine, I think I came so close to having the design for the official Uno. This is the 2011 module, and I checked the spec. I checked just before this. There have been, where was it? 34,000. I've lost the number. 34,880 of these boards have been produced in the last 10 years. EtherMega R3 is the EtherMega, which is an Arduino Mega style board, which has the come on, it's basically an Arduino Mega with Ethernet. I don't know what else I can say about this. It's this is the current version, which has got the WIZnet W5100. After I get the Ether Uno all sorted, I'm probably going to also do an updated version of the EtherMega, which will have the updated Ethernet interface on it. So it's got the ATmega 2560, yes, 2560 processor. It's got the WIZnet interface chip, and you can see this one combines 4 sheets into one because this is a very old design before, yeah, oh, that was updated 2017. But it was...
FreeNFET 3.
What? FreeNFET 3, okay. So FreeNFET 3, I can't say that. It's a tongue twister. This is a board that exposes switched MOSFET outputs as if they are what we would call neopixels. So what it does is use a WS2811 driver chip, which is the same, basically the same silicon that's inside like an addressable RGB LED, and it, instead of the red, green and blue outputs going to LEDs, it uses them to switch high power MOSFETs, so that you can switch 20, 30 amp loads. So what you could do is have something like a red, green, blue traffic light and use this and address it as if it's a neopixel. And you can daisy chain them, so you can switch relays with them, you can change, control high power loads or whatever. That's quite cool. I like that one, even though it's very simple.
FSI6 CAN.
FSI6 CAN is the FlySky. I've got to go to the other section. It's a FlySky interface with a CAN bus on it. I lose the first 15 seconds of each one just trying to find the file. So this is to allow something like a FlySky remote control to be linked to CAN bus, so that it can be controlled from something like a wheelchair joystick. So like a wheelchair control system can be used to fly a drone or an aeroplane or drive a remote control car. It fits inside the back of the FlySky transmitter. It's got an ATmega 328 in it. This has been through a few revisions now. We originally had a 32, no, what did we have in there? Some other processor. Anyway, it's got the CAN bus interface, and it's got outputs that fake the joystick position. So what we can do is send CAN bus messages to the transmitter, and it moves the joysticks and lets you fly.
FW201 flashing LED.
Fly by wire. Oh, flashing LED. Okay, Funway Volume 2 flashing LED. This one, I talked about this one a little while ago on a different live stream. This was a thing a couple of years ago, a few years ago now, where I wanted to bring back some of the Dick Smith Funway projects. So I re-implemented many of the designs, a lot of the Funway version 2. And the idea was to bring back a series of projects that were educational in terms of electronics building blocks. So they were very small projects that would be kind of a fun thing to build, but that would illustrate some fundamental principle. So in the case of this project, it's a flashing LED, but it's actually teaching you about astable multivibrators. And so the schematic and the PCB is deliberately designed to look very similar to the original Funway Volume 2 PCB. Game is a game controller interface with an OLED on it, and it's in the form of an Arduino shield. So I made some prototypes of this and never actually put it into production for whatever reason. It's one of those things where I messed around with it and then didn't know if there'd be interest, and I just never followed through on it. So you can see it's got Arduino headers on here. There is a joystick interface, there is a keypad, it's got piezo, and there is a space for an OLED. So on the PCB, what happens is that this board plugs onto the top of an Arduino, and it gives you a joystick on the left and then the D-pad sort of controls on the right. So you hold it in your hands like a game controller, and there's an OLED that sits right in the middle here. So there's a 128 by 128 full color OLED display. So it's like a little game thing. You could either use it as a controller or a self-contained game. Goldilocks is a board that I did with Philip Stevens. I spoke about this on the live stream and showed it in a bit more detail just last week, I think it was. It is the one that inspired the baby bear, which I think we've skipped the baby bear. No, we did the baby bear. So this is an Arduino compatible board with an ATmega 1284P on it. So once again, lots of RAM, lots of flash. It's got everything configurable. You can see all the cut track jumpers here so that you can isolate different parts of the I/O. It's got ATmega 32U2 with all of its I/O broken out, and it's got a switch mode power supply. So this is like a super Uno. It does everything. It's the everything in the kitchen sink sort of board. And you can see that it's a little bit longer than a regular Uno. This white part on the end is the extended section because it's got extra headers that wouldn't fit.
Hand heater 2.
Hand heater 2. This is a really cool project that I've worked on first with Nick and then with Chris. And one of the things that's cool about it is that it's two PCBs that mount at 90 degrees to each other and they interlock. So this is a heater that goes on a wheelchair, or it can be used just on a desk for people that have problems with their hands being too cold. It's got an ESP32 on it, so that it can be linked to something like a smartphone via Wi-Fi or Bluetooth and controlled. Now, this is the horizontal control PCB, and there's nothing much to see on there. It's got temperature sensor and all of that sort of stuff, controls. But there is also a second PCB, which is this one, which has a routed out of the middle of it. This mounts vertically through the first PCB, and these pads need to be soldered together. So they end up at right angles with a fan and the heating elements mounted sticking up directly from the controller. HomeSense Basic is I actually designed a series of little devices and it's got a weird shape because reasons. This is an ESP8266 with some sensors on it, and the idea is that this is a home automation sensor device, and you could deploy them around your house, like stick one in every room, and it measures temperature and humidity, and what did it do, barometric pressure? I can't remember. No, I think this was the first one that didn't do that, but I've done different versions of it since. Never actually released this project. The reason this is such a bizarre shape on this PCB is that it needs to fit into a little enclosure, and there is a space here where the temperature and humidity sensor folds into the PCB to make the whole thing really thin and flat, and there is thermal isolation over here. Oh yeah, there's the other sensor. So this is a temperature sensor, and the PCB necks down at this point to minimize heat transfer so that the temperature sensor is totally isolated.
I2CPA and EL.
What was that? Oh, I2C panel. This is part of the upcoming light switch project, and I've just been working on that. In fact, it's around. Just over the last couple of days I've had this open. This is a control panel that goes into a rack mount case to make a light switch controller, and it has okay, IO expander. So it has some uses an MCP23017 to address front panel controls, and it's got a header for an OLED. There's no processor on this, you'll notice. This is the total schematic. This PCB is designed to mount vertically just behind the front panel, the control panel, and it provides the display and the input buttons, so menu buttons, but it then plugs into a Raspberry Pi or an Arduino or something else that is mounted inside the enclosure, and that's what's actually doing the logic.
I2C RJ45X24.
And the other thing that it plugs into, so this can go into the same enclosure. This is a series of 24 RJ45 ports that provide inputs from light switches that can be around the house. There's going to be a lot more coverage of this because I'm going to do a whole mini-series about light switches and light switch controllers, which is going to include this. So this is spread across 4 sheets. 3 of them are almost the same. It's got 2 MCP23017 GPIO addressable drivers here, and these are the RJ45 sockets. And so what this allows you to do is daisy chain one of these PCBs with that last PCB I just showed you, all on I2C. So you've got 96, is it? 96 addressable I/O lines and an OLED and a control panel and Ethernet pass-through. IOSEC 8. Okay, so this one is actually kind of intriguing. It's a very simple circuit, but it has some interesting things about it. It's just the same circuit repeated a few times. This is a security sensor interface board, and what it illustrates is end-of-line sensing for security sensors. If you've got a passive infrared detection system like a motion detector, the way they work is that there is a thing called an end-of-line sensing resistor at the end, and your controller needs to measure the resistance through the sensor. That means if someone cuts the wires to the sensor, you can detect it, and if they short circuit the wires to the sensor, you can detect it. And so what it does in this case is it's using analog inputs running into a voltage divider, and there is a resistor that is at the far end of the system. And so what this allows you to do is connect up to 8 security sensors and detect the state of the sensors. Kitten, oh, I have a soft spot for this project. Kitten is a kit version of the 2010, and I did this because what I wanted was some kind of an educational board that people could assemble themselves. It's an Arduino compatible board, and you can see here it's got the ATmega328. If you look at the schematic, it's pretty much a standard Arduino sort of thing, except that it doesn't have the USB interface. It has a programming header for an FTDI cable just up here, and it's all through-hole parts. So this entire thing can be assembled as part of like a workshop, or if you had students you wanted to teach them about a bit of electronics assembly and leave them with something useful. This is an entirely through-hole Arduino compatible board, and you just plug in the FTDI cable and you can load it and use it just like a normal Arduino, but you build it yourself.
Leopard Mini.
Leopard Mini. Oh, this is the thing I was waving around earlier. It's the custom keypad that I use for setting the macros, like what just popped up into the little Eagle console there. It is an ATmega32U4, chosen because it does USB human interface device emulation, and there is a matrix over here. So the keypads are in a matrix with rows and columns, and when any button is pressed, it shorts together one row and one column, and it can then be detected. So there's a USB-C interface, there is a header up here for an ICS, oh, it's not ICS, over here, OLED. It's got the little OLED, so when you press a button, the ATmega can do something. It could send a keypad event, it could send a mouse event, or whatever. I'm using it to send macros that go into Eagle. So I can do things like, well, what I'm doing right now, switching between the schematic and the PCB view. I'm doing that by pressing one button and running that. That is changing layer visibility. So, what? Oh, LibreSat ground test breakout. LSGTB, I had to think about what that was. This is a breakout for testing satellite PCBs in a vacuum chamber. And you can see there is the socket on the left here, which goes into a wiring harness that passes through the wall of the vacuum chamber. All of this is mounted inside of it. And there is a connection here. It's kind of like a test rig. It breaks out a number of I/O pins over here, and you can take your CubeSat satellite board with the PC104 interface standard, mount it onto this PCB, and then put the whole thing inside your thermal vacuum chamber to do remote testing. So you can power up the board and run it remotely and use test equipment on it when you're not physically touching it, and it's inside the thermal vacuum chamber.
LSPPM.
LSPPM. I've got a couple of LibreSat related projects here. Come on, open. Payload processor module. So this is the board that actually went into space on ArduSat-X and ArduSat-1. It is the payload processor module, which has got 17 processors on it. I'm going to switch to the... come on. Okay. The schematic view is probably not that interesting. You can see there are a lot of sheets in this schematic. So 19 sheets. And I'll just jump to one in the middle. You can see payload processor node 5. It's got an ATmega 328 on it. And all of these are on a shared I2C bus. And this board went inside the satellite and allowed you to run up to 16 experiments simultaneously with total sandboxing, because each one was running on its own dedicated processor. And there was a management processor up here that would
LSPSM.
tell each of the experimental nodes what experiment to be running. LSPSM is a power supply module for a CubeSat satellite, and I worked on this one as an experiment because what I was wanting to do was come up with a complete satellite design that could be used in a classroom environment, and this is a power supply module for a satellite. So it's got an ATmega 16U2. Why did I use that? I have no... Oh, that's right. That's USB serial interface. It's got an ATmega 328 on it, which might sound very strange, but the idea with this was that this was to be used in a classroom to explain how the different parts of a satellite work. So it had inputs from solar panels and from external charging, and what I wanted people to be able to do, now it's got current sensing on multiple power rails, so I wanted students to be able to experiment with things and load their own code onto it.
LeoStick.
So using the Arduino IDE was part of doing that. LeoStick is it's basically an Arduino Leonardo in the form factor of a memory stick. And I did this board, when was it? Version 1.1 was 2011, but I think it might have been 2000. Oh no, it was late 2011. And this board was then given away to everybody who came along to LCA 2012. So it's an ATmega 32U4, just like the Arduino Leonardo. It's got an RGB LED on it. In fact, it's got two. Why is that? Oh, one of them is for TX and RX and I/O headers. But the whole thing is squashed down into a PCB that is the size of a USB memory stick. It's got all of the Leonardo headers on here, and the PCB itself is what forms the USB plug. So this had to be manufactured on thicker PCB than normal. I think it was 2.4mm PCB, so that it would be the right thickness to go into a USB port.
Light switch original.
Light switch original. Oh, I included this one because this shows some of where things have come from with light switches. This is the very first light switch PCB that I did after hand wiring the first couple. And this was done when? 2010. So this is what was in all of my light switches, and it was plugged into an Ethernet shield and an Arduino, so that and then this was mounted through a wall plate, and what it would give me is illuminated light switches. Now this was a bit of a failure because it was all done in pairs. In my head, what I thought would be really useful would be to have on and off buttons for everything. So you have lights on, lights off, and fan on, fan off in the bathroom. But it was just totally confusing. Nobody could figure any of the buttons out. And so all of my light switches now are simplified. They just have a single button like toggle. So you press it once, lights turn on, press it again, lights turn off. But this version had pairs of buttons, one for on, one for off. And that was terrible. Moke is the mini open adaptive controller, which I'm stalling here. I should have put a counter on this because I have no idea how far through this I am. I showed this on a live stream just recently as well. So this is ATmega32U4 once again, so that it can do USB HID emulation, takes inputs from assistive technology devices like buttons or like a foot switch or a chin switch, and sends arbitrary events to a computer. So it's a bit like the Xbox adaptive controller, except it's fully open source and it can do a whole lot more. Oh, Mako just said, is there an ORAC too? Okay, I don't have time to think about that.
PCD.
What is PCD? Oh, PyCan display. That's right. These acronyms don't mean anything to me after a while. So this is a Raspberry Pi hat that has power over Ethernet support. So if you put it onto a Raspberry Pi 3B Plus or a Pi 4, which have got the PoE headers, it will allow you to send power over Ethernet to the Pi. It also has a CAN bus interface and an OLED. And the idea with this, what Chris and I have used this for is on a wheelchair, connecting this to the wheelchair so that we can use a CAN bus interface with the Raspberry Pi, and the Pi can then be paired with a Bluetooth game controller, and you can then use the game controller to send CAN bus events, and you can read CAN bus events and display them on the little screen. So very useful if you want to connect a Raspberry Pi to a CAN bus network.
Phone.
Oh, I love this project. I'm so sad that this kind of doesn't really even exist anymore. This is an Arduino compatible mobile phone, and this was done a few years ago for Open Hardware MiniConf as a way of showing people how mobile phones work, like what the major components are within them. So there is the main processor here, which is an ATmega 1284P, and there is a USB interface, but up here there is a GSM module. Was it the ADH8066, which is obsolete now because I think it's only it's like a 2G module. There's a keypad matrix and there is a display that goes on it. So this is actually sideways. If you held it in a vertical orientation, it's like a Nokia phone, but it's an Arduino. So you can make phone calls on it and everything.
Status shield.
But you can write your own firmware and do whatever you want on it. Record status shield. Now this one I included just because it's very simple, but it's kind of a weird story. In the early days of IVT, when was this? 2013. Someone from New South Wales contacted me and wanted a whole lot of prototyping shields and 11s, and it turns out that what they were doing was building a status display to go into all the New South Wales law courts, and they were showing whether the audio recording was currently functioning properly. So this is a very, very simple thing that just drives a couple of big, highly visible displays, and if the audio recording fails for any reason, the monitoring system detects that and it sends a signal, and it uses this to flash up a big light so that the proceedings in the court have to stop because they can't continue with the court case if the recording system has failed.
SensorBreast.
SensorBreast is a project that I helped Kathy Reed out with. This is for a prosthetic Sorry, my brain is fading at this point. So this is a project that Kathy has been working on for a couple of years now after a mastectomy, and she built a prosthetic that has sensors in it. And so what I did was make a hat for a Raspberry Pi that incorporates some environmental sensors that she wanted to log. And this is all mounted into a very unusual form factor, so that she can physically wear this device. And it's got an IMU on it, so it does movement detections, a heart rate sensor interface, and it will display an environmental sensor, so it can detect organic compounds and temperature and humidity and all those sorts of things.
Sharp-line controller.
Sharp line controller. So this is the SuperHouse blind controller. I've never actually shown this because I did this as a commercial project many years ago, but the client I did it for is no longer doing this job, so I can show it. This is a very long skinny PCB that goes inside the rod of a blind, and it controls a motor. So it's got the spark core header down here, and originally we were using spark cores and then particle photons, and then we switched to ESP8266, hence the ESP core project that I showed you earlier. This takes mains input, and you'll see on the PCB that there are two distinct halves. Mains is over this side, and then there is a radio receiver here, 433 megahertz receiver, and a Hall effect sensor so it can detect rotation of the blind and it can count. So what you can do is set travel limits and send a command, and it will open or close the blinds and stop at the appropriate place.
Smart control.
Smart control? Where? Smart control? What is smart control? Oh yeah, okay. This is the control board out of my next generation light switches, although when I say next generation, this is actually a couple of years old. I've just never actually really finished it properly. It's a board that goes in the back of a light switch, and the controller itself is generic so that you can have different interface surfaces with the same controller. There's an ESP8266 in here, and what it does is provide an RJ45 connection with switched outputs so that you can either communicate with it over the wire or by Wi-Fi. And if I switch to the PCB, switch, come on, give me the PCB. So there's an RJ45 socket on here, there's a voltage regulator. So what you could do is just run power to this and run it otherwise totally unconnected and communicate by Wi-Fi. Or you can plug in an RJ45 socket. It doesn't use Ethernet, it has switched outputs. So it's compatible with my existing light switch controller. Super button is a, is that where it is? Yes. Not even sure if this is the most recent version because I've just been moving projects around. No, yes, this is the most recent version. This is a nurse call button that uses a load cell so that the force that is required to activate it can be changed to suit the individual user. And Chris and I built this so that it could replace his nurse call button that he uses at night. So when he's lying in bed, he has a button in his hand, and if he needs assistance, he can squeeze it. And rather than having a mechanical actuation that has like a spring and some kind of a mechanism that can be hard to press, this just measures how hard he's squeezing it. So it has an input from a load cell, it's got an output to an OLED, there's a my brain is fading. There is a knob to control the menus.
Screen for 3.
Test. We're up to T, which means we must be getting close to the end. This is a test board. Earlier I showed you the free NFET3 module, which is the addressable, which is 3 MOSFETs, which are addressable just like a NeoPixel. This is actually the test harness for it. So these large pads here are for pogo pins, and there is a tactile switch that goes in the middle. So what you do is have a test program that runs on the Arduino. You take the module, put it onto the pogo pins, push it down. When you push it down, it activates this button. The Arduino detects that. It then runs the test procedure and gives you either a pass or a fail at the end of it. So the LEDs come on to show test has started, and then it either passes and it goes green, or it goes red and it says it's failed. And what it does is it measures the pass-through of the module. There's actually another WS2811, so it can detect failures on pass-through.
WEARSP32.
Oh, where is P32? This one is also a funky one. I like this one. This is because my daughter a couple of years ago was doing a school project where she put some fiber optics and some LEDs into dresses that she designed. And this is like a lily pad. So if you've seen the wearable Arduino stuff, this is like a lily pad but with an ESP32 on it. So there's a Vroom 32 here. Oh, what's that? It's a weird footprint. I haven't used that footprint for a while. And basically just breakouts for a whole lot of the I/O. There's some power management, there's a voltage regulator. So what you can do is on the socket down here, you can plug in a single cell LiPo and then you can sew conductive thread through these large holes to connect to the I/O. So what you can do is have like Wi-Fi enabled smart clothing that can turn different things on and off, or Wi-Fi or Bluetooth, or whatever you want to do with your ESP32. So it's a wearable ESP32 board. Hence the name. WMC. Oh, wheelchair motor controller. This is hardware. I've got to dig down through another directory here to get to the right file for this. This is a complete replacement for the motion controller of a wheelchair. And in this case, it's got an ATmega32U4 on it. I don't know why I used that processor on that. It doesn't really make a whole lot of sense. And there is a header that goes to a RoboClaw combat robot motor controller. So on the board, what happens is that there are these holes here are for clinch nuts. So the combat robot motor controller bolts onto those 4 mounting points, and then there are big connections down here for power coming from the battery and going out to the motors. CAN bus interface, USB interface. W. Have I run out? I think I have. Okay. Just as my voice was starting to fail. That was probably no use at all in terms of understanding what any of those projects were. So I've run down my 50 minutes talking at maximum speed, and we can take a little break. Now, just something to keep in mind is I barely had time to mention any of those projects in particular, and so that was 50. The way I did this was I went into my Eagle projects directory and I just did ls-1 to generate a list of all of my Eagle projects, and there were more than 300 of them. So then I just went through and started deleting projects to try to narrow the list down and come up with 50. So if you it's kind of exhausting to go through 50 projects like that in 50 minutes, and then to think that was only 50 out of more than 300. So I can take a breather now. And maybe switch to I could talk about any of these in particular, or a chat, or whatever, and relaxed. That was intense. I don't know if it was such a clever idea. If I'm going to do like a series of project lightning talks again, maybe I should change a few things. One, maybe I should make it 2 minutes per project instead of 1 minute, or even longer. Like I could make it 3 or 4 or 5 minutes per project, and just do a few, like do I don't know, 10 projects in 20 minutes. And I should also figure out a way to have the script automatically open the right project in Eagle so that I can just talk about it. Anyway, that was kind of a stunt more than something that was actually useful. Had to be 50 and 50. Oh, Jackie. So Jackie Lees is my sister. And Popper's at the end of each. Yeah, 2 minutes, 20 projects max. Yeah, that sounds more sensible. Okay. So we've got to got to catch up on a lot of chat, I think. Now, where are we? Stuff, system log, streams. All right. So, just jumping up into. Why can't I get focus on there? All right. A couple of questions. Yeah. So. Breathe, breathe. All right. Thanks. Thankfully, while I've been totally ignoring chat for the last 50 minutes, Andy has been paying a bit of attention, and he's highlighted a couple of things for me to go back and look at. So Tyson asked whether anyone else has been looking at or using Rust for ESP32. That is something that I've been meaning to look at and haven't. Now, this opens up a whole lot of questions about languages, and I know there are many people, like Sion in particular, who is in the chat here, who are big fans of MicroPython, and so Damien George, who I think is the lead developer as MicroPython, is here in Melbourne. At least he used to be. I'm not sure if he's back. I think he might be. And so there is a lot of MicroPython interest, obviously geographically, right here in Melbourne. So when I first heard of the idea of MicroPython being, let's take a microcontroller and put Python on it, it seemed wacky to me. But that was just my first, my initial reaction. And it is actually much more sensible and much more powerful than I had originally thought. So MicroPython, I think, is a really interesting thing as well. Rust is intriguing, and I don't really know very much about it, other than having seen it mentioned a few times at LinuxConf AU, for example. Rust has come up a couple of times. There have been some talks about it. And what little I know about it is that it is intended to be C done right, I think is probably the best summary. So I think what it does is protect you from a whole lot of things that that you can bite yourself with in C. C is obviously a very old language, and things have changed a lot. So I could be totally off track there, but I'm looking at Rust is something that has been in the back of my mind for a while, and I've just had too much to get to. But I would love to hear of other people's experiences with it. So, oh, and Tyson also, oh, was it Tyson? So, a couple of suggestions. I think these might be for from Andy, who said what I should do if I'm going to do like a project series of lightning talks like this. I should have a countdown timer, which is progress indication of the projects, like project 7 of 12 or whatever. So we know how far I've got through it. Maybe even a progress bar. So there was a question that I did notice earlier in the chat, from, which was, is there an ORAC too, which is in relation to the MOAC, which is the Mini Open Adaptive Controller. Is there an ORAC? And what made me have a brain fade at that moment was I couldn't figure out what ORAC was meant to stand for. Open something adaptive controller? I don't remember what the R is. I don't know what it stands for. But the reason it's actually called the Mini Open Adaptive Controller, and there is no Open Adaptive Controller, is that I started by designing the Open Adaptive Controller as a full-size thing, because originally this all came about when the Xbox Adaptive Controller was announced. And it was announced, excuse me, it was announced, Aaron, thank you very much. That's really generous. Um, it was announced many months before it was available. There was a pre-order system, and when it was announced, Nick ordered one. I think he ordered one like the day it was announced. Oh, Orac is from Blake 7. Oh, it's so long, so many years since I've seen Blake 7. I don't even remember the Orac. My memory of Blake 7 is hazy. And so we ordered it. Well, he ordered it. And it was going to be a couple of months before it arrived. And in the meantime, what we started doing was designing the Open Adaptive Controller. And what we'd seen was photos of what the Xbox Adaptive Controller was going to look like. We thought it was a really cool idea, but we wanted something that wasn't just a game controller. We wanted also to be able to do keyboard events and control a computer and make it much more flexible, so from a software point of view. And so we started with the Open Adaptive Controller, just doing a full-size version. And there were going to be all sorts of mechanical issues with things like the buttons. This is probably a project I'm still going to get back to. As cool as the Xbox Adaptive Controller is, I like the idea of having something that is fully open source, including the hardware and the software, so that you can control exactly how it behaves and make it come up as a different type of device, make it be whatever you want it to be. The Xbox Adaptive Controller is a fantastic building block, and you can be flexible in terms of what you plug into it, but the building block itself is closed. So I want to do an open version. And anyway, what happened was that I was starting on the full-size version, and then I thought, let's just do a simple one to start with, and we'll prove the concept. So we did a massively shrunk down one, which is just the breakout with the sockets along the bottom. It doesn't have any built-in controls. It's just got the inputs, and it only has 8 inputs. It doesn't have the 19 of the full game controller. But I will probably do an open adaptive controller as well. So Ryan KS12 said, do you ever use Altium for your PCB designs, or has it always been Eagle? I have used Altium very briefly. So my first PCB designs I did, how old would I have been? I must have been about 12 years old, somewhere around there, and I did it using pencil and paper, and then drew the designs using a resistive pen on blank PCB material, and then used ferric chloride to etch it. So my very first PCB designs were actually just drawn by hand on the physical PCB. That was how it came about. But I would plan it out first on a piece of paper. So I would figure out where the parts are going to go and then draw lines on the paper. And typically what would happen is that usually you'd have the parts on one side of the paper and the tracks on the other, because I was just doing single-sided PCBs back then. So what I would do is take the piece of paper and I would turn it over so that I was looking through from the back of it, put it onto the PCB, and then I had in fact I think I still have it. For many, many years now, I've had a little tool, it's here on my tool bench somewhere, which is like a sharp point, like a needle with a handle. And so what I would do is poke into the copper with each of the PCBs, and I'm getting so far off track here. And then I take the paper away, and I would just have blank PCB, but there would be a little pinprick dimple where the center of each of the holes needed to be. And then I would use the Dello pen, and just by eye, I would draw all of the tracks on, and then etch it. So then I can't even remember what the first actual PCB design software I used was. It would have been when I was maybe 16 or 17. I think it was called MacCAD, something like that. and it had no intelligence at all. There was no schematic. It was literally just a grid with lines, and it would snap to the grid, and you could like drag a track, snap, drag a track, snap, and then you could print it and use it for photo transfer or whatever. And I used OrCAD at some point, OrCAD PCB, and there was some other precursor to Altium. Before Altium Designer was called Altium Designer, I think it was called something else, and I used that briefly as well. But in the sort of modern era of tools, the one that I've used the most is Eagle. I have used KiCad a little, and even less than that, Altium Designer. And one of the major Protel. Thanks, Peter. Yes, Protel. Protel Easy Tracks? No, something. I can't remember. Protel PCB? Yes, I used that way back. But one of the major, three major reasons that I haven't really used Altium. Number one is that I'd need a Windows machine. So at the moment, I do run it very occasionally, very rarely, and I have to run up a Windows VM in order to do it. In fact, I've got a very old copy of Altium running on a Windows 7 VM. So if I need to access a file, then that's how I do it. The other is the cost, and I last time there was some project where a contracting client said to me, oh, that's right, I remember who it was, but yeah, I can't talk about that because I had to sign an NDA. A contracting client said to me that they wanted me to use Altium for all of their projects, so I would need to get a license for it. And the old license that I had, that I've got in my VM running on Windows 7, is too out of date. So I contacted Altium and said, I need an updated license. And they said, sure, give us $5,000, please. And I said, no. And that was the end of that. I think it was $5,000. It was like $5,000 or $10,000, some insane number. Yeah, 10 grand. So I kind of didn't. And the other reason that I don't is that, and people are going to say, well, why are you using Eagle? Is that it's not open source. It's basically as closed as it can possibly be. And so KiCad is obviously much better in that respect. And I'm possibly going to end up using KiCad over time. I've been saying that for years. Every now and then I still use it for some project. Some Freetronics projects have been designed in KiCad. In fact, when Angus, who is here in the chat, was working with me doing projects for Freetronics and SuperHouse many years ago, he designed a number of Freetronics projects using KiCad, and we published a Freetronics KiCad library at the time, and some Freetronics products that are shipping now were designed in KiCad. Angus says, come to the light side. Yeah, but then I don't get all of the 3D integration and everything. The problem, if Eagle / Fusion 360 was still the same as it was 2 or 3 years ago, I would make the jump. But the Eagle team, I don't know what they're drinking, but the last couple of years they've been going nuts. New releases like every 3 days and new features constantly. And I know some people complain about it, but the Fusion 360 integration is just crazy. It's so cool. So typically when I'm working on projects now, because I've got 6 monitors here. So I've got 3 on my main computer, and what I normally have is the schematic in one view, the PCB in one view, and the 3D in the other view. And what I've found is that the process of doing design with the 3D view right there and synchronized, is it changes the way I think about things. And it's, let me see if I can find an example. All right, so, well, actually, the air quality sensor, that's a good example. I'm going to pull up the, open Fusion 360, and hopefully it doesn't kill my live stream too much. And show you the air quality sensor. It, thinking in 3D as I'm doing the PCB design has really helped me a lot. Oh, Scott said KiCad has a 3D viewer. Cool. Peter says get a bigger monitor. No, there are no monitors big enough. So I've got 327-inch monitors, which are, the resolution is 2560 by 1440 or something, or 1200. So yeah, you know those massive, like 49-inch curved screens with the crazy high resolution that you can get? That's still only equivalent to 2 of the 3 monitors that I've got. So that would be a step down in screen space. And being able to see the project in all those different contexts is really useful. So yeah, I need to look back into KiCad again. Let's have a quick look at more comments. So Kate said that someone else had asked if PCB design is part of a degree or if there is another place to learn it. Yeah, it very much depends on the degree. So PCB design, I'd be interested to know of the people in the chat as how did you learn about PCB design? That is a really good question. For me, it was just messing around with my own projects and learning things as I went, copying designs out of magazines. So when I was a teenager, there were some magazines that were produced here in Melbourne called Talking Electronics, and also the old Electronics Today International and Electronics Australia, and even things like the Dick Smith Funway. A really common thing to do used to be in all of these sorts of magazines is to publish artwork for PCBs. And typically boards back then would only be single-sided. So what you could do is there would be black and white artwork reproduced 1-to-1 scale in the PCB, and you could take the magazine along and put it in a photocopier with an overhead transparency sheet, and you would copy the artwork from the magazine onto the transparency sheet, and you could then use that for a photographic transfer onto the PCB. So my early exposure to learning about PCB design, I think, was probably looking at what other people were doing and emulating what I was seeing in these sorts of designs. Yeah, Peter says Electronics Australia, Silicon Chip represent. Yeah, so Silicon Chip is the other one that that I used to get. I'm sorry, I got off track earlier of showing some integration, but it's probably not worth going into this in great detail now. Come on, where is my air quality sensor project? Oh, there it is. Too many projects in Fusion 360. So what I find is that having assembly, yes. Here we go. I will switch to desktop. Oh, I'm seeing a whole lot of tearing on the video. It's probably my computer struggling right now while it's doing things. Hang on, I'll clear that timer off the screen. Clear timer. Bye-bye. Yeah, so while that is opening, I'll go back to the back to Eagle and see if I can find, performance issues. Yes, I'm trying to get my 7-year-old computer to do way too many things at the same time. Got to find projects. Air quality sensor. Somehow in my random clicking around, I've reversed the sort order on the projects list, so it's in reverse alphabetical, which has then just totally screwed me up. Alright, so this is the air quality sensor project. So normally what I would have is these 3 views open on the 3 screens all at the same time. So they're all in physical view, and you can click on something in one view and it highlights elsewhere. So you click on a net in here and it highlights the track on the PCB, etc. Which I know you can do in KiCad now as well. But it really used to bug me, the disconnect between the schematic and the PCB in KiCad. So what we've got here is the PCB view, and the schematic view, and then I'll go to the board view. So we can see there what that looks like, and this gives you a reasonably good idea physically of how it's laid out, but it is still a little bit deceptive. It can not necessarily give you the best idea of how everything fits together. So we've got some parts on the front of the PCB, there are parts on the back of the PCB, and then if we switch over to the same thing, so this is the same project synced into Fusion 360, what we can see is the PCB with the sensor sitting on top of it, and where are we? So, and I'll get rid of the case. So we've got the PCB, there's the ESP32 and the button on the back, and being able to spin it around and look at it in this view really helps me to understand how the different parts are fitting together, particularly when it comes time to making an enclosure. And you can see here that there is the laser particulate matter sensor attached to the front of the PCB, and if I turn that off, you can see that there is the socket on the PCB that the laser sensor plugs into, and then there is the display that is on risers here, so it sits up on top of an extended header, and it comes over the top of the sensor and sits in front of it. And so this sort of view I've found is incredibly useful when it comes to understanding how things are going to fit together. If I'm in the PCB view, sure, I can extrapolate from this flat 2D view and think, okay, so I've got these addressable RGB LEDs up here. I've got them in the corners because I want the air quality sensor to be able to glow different colors depending on, if you've got dangerous levels of something in the room. Say it detects that you've got a gas leak. I want to make the case flash red so that it's getting your attention. And you can see up here that the LEDs are mounted up there, but it's really only when you switch into the full 3D view that you start to get an idea of how they work together, how the different parts of this fit together, and the LEDs here being a fair way back from the front, which could be okay if it means that you've got a semi-transparent case and you want diffused lighting. But yeah, I just find that it helps me to understand it a whole lot better having those 3 schematic, PCB and 3D views all open in front of me all at the same time. And even from quite early on, as the project is developing, I suppose the traditional process of electronics design is extremely linear. You start with specifications, then you do a schematic, and on big projects the schematic will actually be designed by a different person to the person that does the PCB layout. So what happens is you get someone who designs a schematic, and they'll put notes and hints in the design about things like put these decoupling caps close to these power pins and those sorts of things. But they then just send the schematic off to a totally different person, and that person receives the schematic, looks at the notes, and then lays out the board. And then the board goes to someone else to be integrated into an enclosure. And so you have these little silos of the process. And that's kind of the way I used to do it as well. And I found that I think my designs have got better in recent time, partly because I'm much more aware of the end of the process now, not just the start of the process. So yeah, I really like that Eagle Fusion 360 integration. But yes, KiCad is developing rapidly as well, and I need to put some time into looking at that. Alright, so Scott asked what was the name of the keyboard input project. I've actually shown several. So there is the little custom keypad that I use on my desk. That is the Leopad Mini. So it's an Arduino Leonardo keypad. I'm so good at naming things. Chris mocks me for my naming. And I've done a couple. There was the little keypad, which is the Leopad. I've never actually released that as a project. It's up on GitHub. The design's been up there for a couple of years now. And I've also done the mini open adaptive controller, which can be a keypad, but I'm not sure which one you're talking about. So people are talking about longevity of machines. Yeah, so what I'm actually live streaming from right now is a 2013 iMac. And so Scott just asked, is the Leopad Mini available to purchase? Right now, no, but that's just because I have... The honest answer is that this is a project that I was going to be making myself, and it's got a couple of QFN parts on it, and I hate assembling boards with QFN parts, so I never released it. How stupid is that? I know Sion eats QFN parts for breakfast. It's like sort of a bowl of muesli, has a bowl with QFN chips in it and just crunches through them thousands of times a day, thousands of them a day. But yeah, I don't like assembling boards with QFNs. They're hard to get the solder paste right, hard to get the placement accurate, hard to test because you can't see, hard to rework. It's all relative. I mean, I do rework QFN stuff, and I actually do it fairly often. It's not that bad. But the idea of sitting down and assembling hundreds of boards, I don't really like that. So the problem is, the part of the process that I like is designing things. It's not necessarily the grind of, oh, okay, now we've got to assemble 1,000 of these, which is not at all a fun thing. Sion, so I'm going to spend a day doing QFN with you. Yeah, well, I do have QFN on a few of my boards now, like the ESP prog has a CP2102N on it, and yeah, I've got a few boards with that sort of thing. Cable tie. Yeah. Don't mention pick and place to Sion. Yeah, so Mike, you just replaced your MacBook Pro this week. Yeah, so my three main computers are the iMac that you can see here, this, which is my Retina MacBook Pro 2012, and so I love this laptop. It's fantastic. It's been through, so I've replaced the SSD several times. I think it's on its third SSD because I kept running out of space. And back when I bought it, I was too cheap to get a decent sized SSD. And I've replaced the battery 3 times, I think, and the screen has been replaced at least once, maybe twice. I can't remember. Apple replaced the screen under warranty when it was about 5 years old, which was awesome. That's one of the things that Apple sometimes do right, is when they have a problem, sometimes they totally deny it, they say it doesn't exist, and sometimes they do crazy things like issue a recall and do replacements on things that are years and years out of warranty. And so I've had one of my battery replacements on this, and the screen replacement was done free of charge by Apple years and years after the machine was out of warranty. So in terms of good keyboard and good processor, good screen, that 2012 MacBook is a fantastic machine. But it's mine is starting to fall apart. It's got a few screws missing, and there's some ghosting on the screen again now, and I'll need a new one at some point. But it's still going for now. So yeah, 8-year-old laptop, 7-year-old iMac. They're still going strong. And my third main machine is the one that runs the second row of monitors, and that's like a generic x86 Intel box running Ubuntu. I am just about out of time, and I'm going to go and have lunch with my family very soon. I'm going to end pretty much on time today because I'm tired after that 50 and 50 marathon. And my voice is failing. What's for lunch? I don't know. I've been told that there is going to be a special birthday lunch. So there's no birthday dinner tonight, but it's going to be a special lunch instead. So, thank you very much to everyone that contributed super chats. I really appreciate to be honest, I do appreciate the financial support. I don't do this for the money. I do it because I love it. But the super chats do help. And thank you for setting off the poppers. The internet of poppers worked better than I could possibly have expected. Thank you also for all of the birthday wishes. I hope you all have a fantastic weekend. I'm going to go and have some cake. Yes, I was cringing for the next poppers. For the next popper. Oh, one final thing. It's been a little while since my last proper SuperHouse video, and that is because I've been struggling with episode 4 of the air quality sensor mini-series. And a couple of days ago, I realized why I was struggling with it. It's because what I was trying to cover in that episode wasn't quite fitting the sequence. I had this plan for 5 episodes, and episode 4 was not working out what I expected it to be. So what I've done is I've refilmed a bit of it, and I'm going to release another episode which is going to be all about how to do data logging and reporting using MQTT, Node-RED, InfluxDB, and Grafana. Using those 4 components to make a general purpose data logging and reporting system so that you can generate pretty charts and you can show historical data. But I'm going to release that as a standalone video because it's not just, James said the plan started with 3 episodes. It did, it grew. Because it's not just about air quality. That little stack of software is very useful for all sorts of things in home automation or IoT or whatever you want to work on. And so rather than have the instructions for how to install all of those and link them together within an episode that is specifically about the air quality sensor, I'm going to release that very soon, hopefully in the next few days, about how to install and configure those 4 pieces of software and set up security on them, link them together, and then you can use them for whatever sensors you like temperature sensors or whatever, and generate charts. And then that will be a useful resource. So then episode 4 of the air quality sensor series will follow after that, and it's going to be using that little software stack and reporting the amount of particulate matter that's in the air and volatile organic compounds, and also a discussion about what air quality actually means, like the different standards that are used around the world, because in different countries they have different ways of reporting it. You'll see different numbers and there are different scales. They can be like from 0 to 1,000, or they can be from 1 to 7 or whatever. So episode 4 is going to be about reporting specifically for air quality, and then episode 5 will be about the Air Quality Sensor Pro, which is the one that I've just been showing as part of this chat. Oh, Nema, thank you very much as well. All right, thank you. I've had fun. I hope you have as well. Oh, Ryan KS12 said, do you have a pick and place machine there? Yes, I do. It's just off camera. It's just there. I've done videos about that in the past. I might show more about that sometime as well. So, I hope you all have a fantastic weekend, and I'm going to go and have lunch with the family. So, farewell. See you in Discord or on the forum, which I need to pay more attention to. Thanks. Bye. This is a voice from beyond. Yes, there is a hot mic. All right, I'm going to stop the stream.